Hi there. Today we're going to talk about midsegments of triangles. Actually, we're going to talk about more than just that, but we're starting chapter 5, and it's all things about segments that you can include within triangles. Starting off with midsegments. This is probably a new term for you. A midsegment is a segment that is going to join the midpoints of two sides. So if you look right here, D, you can see by the markings, D is the midpoint of this side of the triangle. E is also a midpoint of this side of the triangle. And if you join those two midpoints, you create a midsegment. Now here's the thing though, when you draw this midsegment, it's going to have some properties. One of them is that it's going to end up, DE, that's the midsegment, will be parallel to that third side, this side down here. So AB and DE will always be parallel. If you think about it, as soon as you create parallel lines, you should be going back a couple chapters thinking, oh, if parallel lines are cut by a transversal, then you're going to have certain relationships. For instance, this angle right here and this angle right here, those would be corresponding angles, and they would be congruent. And so there's different relationships that will still hold true. The other thing that happens is that midsegment DE is always going to end up being half as long as that third side. So right here, if this is 10, then this AB here is going to be 20 units long. Always half as long. Now let's practice constructing one of these before we do anything with it. So to construct a midsegment, that means that you have to find some midpoints. And to do the midpoint thing, you're going to be doing a perpendicular bisector construction. So I can pick, it wants me to construct a midsegment, so I need two midpoints. It doesn't really matter which two sides I pick. I guess I'm going to go ahead and just pick these two sides here. I'm going to find the midpoint of this one and find the midpoint of this one. Let's start with this side. Remember to do the midpoint that you put the point of your compass right here, and you stretch your compass up over halfway. And when you do that, I'm just going to freehand this, but what you end up with is you get this arc through here like that. And now I really don't need all of that arc. Maybe you're to the point where you know you're just trying to create that X. You only need a little bit of that arc. Then you're going to go to the other side and put the point of your compass right here with that same measurement and make another arc. And it's going to look like this. And you're trying to make that X thing happen. Once you get that X, then you connect that, and what you've created right here is your midpoint. You don't need to circle it, but that is the midpoint of that side. All right, let's go over here and do the same thing on the other side. I'm going to put the point of my compass right here, stretch my compass over halfway, make an arc, and then another arc. Do the same thing up top, put the point of the compass, arc, arc, then I'm going to connect those intersections, and by doing that, I have found another midpoint. Now what you do to create the midsegment is you go ahead and draw the line between those two midpoints. So that's the midsegment right there that we want. And it should look parallel to this third side, but it also should end up being half as long as that third side too. That's the construction of it. You'll have that on your homework. I only constructed one midpoint, but if I wanted to construct all the midsegments, then I would need the midpoint for this side down here too, so I would do that same perpendicular bisector construction, find the midpoint somewhere right here, and then I could draw that midsegment, or I could draw that midsegment too, as long as you're connecting two midpoints. All right, let's do a little bit of work with this. Let's assume we have that those midsegments, and this is an example where I have all three midsegments drawn. You can see this is a midpoint, this is a midpoint, and this is. So I've drawn all three. The question is, what are three pairs of parallel segments? Well, let's start writing one. I'm going to write the first midsegment. That's RS. What would that be parallel to? And you can kind of just look at the picture and tell this right here is parallel to this one, because this is the midsegment, this is the third side. So that'd be one option. Let's pick another midsegment. ST is a midsegment. What will that be parallel to? Right. Parallel right there. Segment DF. or I'm sorry, DE. All right, and then your last midsegment is segment RT, and it's going to be parallel to its third side, which in this case would be EF. Those are parallel. So that's the first piece, is parallel. Now let's use those parallel lines. It says, what is the measure of angle VUO? VUO, that's this angle right here. What is the measure of that angle? Well, to do that, we have to look at the fact that you have parallel lines cut by a transversal. And you can see right there that it created this 65 along with creating this green angle that I have marked. And then you have to think, what type of angles are those? Well, they are kind of both in the lower right corner, so those are called corresponding angles. And corresponding angles are supposed to be congruent. So if I would have to say then that the measure of angle VUO equals 65 degrees. Now when it says explain my reasoning, that would be that nice theorem, if parallel lines, then corresponding angles are congruent. You'll do a little bit of this on your Math Excel homework tonight. All right, let's throw some numbers for some side lengths instead of some angles. On this one it says in the figure at the right, AD is 6. Okay, so this right here is 6. DE is 7.5. That's a midsegment, 7.5. What are the lengths of DC, AC, EF, AB? Okay, lots of them. Well, let's start with just that first one. They want to know DC, that's this segment right here. Well, you can see the double hash marks means it's the same as this, so it's going to have to also be 6. So we'll mark that. And then they want AC. Well, AC is just those two sides put together, so that'd have to be 12 for AC. Now look at what they ask next. They want to know EF. EF is a midsegment. Now remember, what's the relationship between this midsegment and its parallel side? Remember, it's supposed to be half as long, and if we just figured out that this whole thing is 12, then this FE midsegment is going to have to be, oops, not that, it is not 12. It's going to be half of that, so it is going to be 6. All right, last one, AB. AB is this entire length here. I don't know any of the parts of it, but what I do know is that this midsegment right here is 7.5, and it's going to be half as long. So 7.5 is half of 15. All right, so we found those all out. Let's go back, and I added one extra question. It says if CB is 10, so let's put that in there. CB is 10. What would be the perimeter of DEF? DEF. Okay, so if I do this triangle, that's the little triangle created from all the midsegments. And if CB is 10, I should be able to list how long this midsegment is. It's going to be half as long. And once I have those three sides, I've got a 5 plus a 6 plus a 7.5. Add those sides up, and I get 18.5 for the perimeter. Now sometimes they're going to give you just numbers, but here's an example where you have to do a little bit of algebra, and this is where it'll start leaning into a little bit more of. It tells me that JK, this thing, is 5x plus 20, and NO is 20, okay? What's the value of x? We have to go back and think about this midsegment here and its relationship to its parallel side. Remember that this is half as long as this. So this right here better end up being, how long do you think? 40. All right. So to do my algebra, I'm just going to set this 5x plus 20 equal to 40. And then go solve. I'll subtract the 20 and divide by 5. And I've got my x figured out. All right, so I'm going to move on. That's about all we got for midsegments. Let's take a look at 5.2. It's on perpendicular and angle bisectors. Let's start with a perpendicular bisector. Now, first of all, let's recap what a perpendicular bisector is. You have this given segment. We're going to call it segment AB. And this CD is what we call the perpendicular bisector because it comes in here and it's perpendicular. You can see the right angle. And it's going to hit at the midpoint, creating these two segments to be the same. That's what it means to bisect it. Now, if this is the perpendicular bisector, what the theorem says is that you can pick any point at all on the perpendicular bisector. Let's say you pick point G. And the distance to the endpoints of that original segment, those distances are always going to be the same. Now, as you move away from the segment and you pick F or you pick E, yes, this is definitely longer, but this one is the same as this one. All right, let's see how we can use that. All right, on this problem, we're looking at, ultimately, it's just a perpendicular bisector. You can see right here that this segment is perpendicular and it bisects segment PR. All right, what we just said, though, is if you pick any point on the perpendicular bisector, let's say Q, if you pick that point, its measurement to the endpoints should be the same, equidistant. So this should equal this. Let's set up a little equation. That means that 3n minus 1 better equal 5n minus 7. A little algebra. Add the 7 to the other side. Be careful. Oops, why did I do that? Add 7 to the other side. I end up with a 6 equals 2n. Divide by 2. N is 3. Now that's nice, but that's not the final answer because they asked for the length of QR. So I'm going to take 3 and I'm going to go plug it in right here. 5 times 3 is 15 minus 7. QR is going to equal 8. All right, let's do the same thing with angle bisectors. Let's say you start off with an angle, this big angle here, and you come in with an angle bisector. You can see it's an angle bisector because these two little markings show that the angles get split into two equal parts. The theorem here says that if you select any point on the angle bisector, let's say this green point, if you measure to the sides of the angle, and when you measure to the sides, it needs to be a perpendicular measurement. It comes straight back to it, and that segment there and that segment will be the same. Here's a point on the angle bisector. Measure to the side of the angle, measure to the side of the angle. You should have the same length. All right, last one. Let's go ahead and use that. Typically, these pictures all kind of look the same on this one, where they give you this big angle. Here's your angle bisector. You can see that it's bisecting, and then they drop a perpendicular. It looks like it's creating right triangles, but ultimately they're just showing you that, hey, that's a straight line distance to the side, that's a straight line distance to the side, and those should end up being the same then. Little algebra, let's set those equal. 4x plus 9 should equal 6x plus 3. I'm going to subtract the 4x to the other side. I'm going to subtract the 3 to the other side. Divide by 2. But again, they're asking for the length of something, so I'm going to go plug that in. If I plug that in right here, I'm going to find that FB is, that's 18 plus 3. FB is going to equal 21. All right, midsegments, perpendicular bisectors, angle bisectors. 3 of them today. All right, good luck.